To solve this problem, we need to square both sides. So we're going to square that entire side and also this entire side. And so squaring the square root is going to cancel out and just leave us with the 2x over on the left. Now on the right, we have to square the entire side, and it's not just one big square root, so it doesn't cancel out nicely. Instead, we're going to need to do what we would traditionally view a squaring as, which means multiply the value by itself. So take that entire side and multiply it by itself again. So here you're going to have to use the FOIL method or the distributive property, however you view it. Multiply every item over here by every item in the second factor here. So this first multiplication actually is the same square root times itself. So that will cancel out a square root. The second multiplication is a -4 times that square root. So it's going to give us a -4 times the square root. All right, and then we need to do the second item here multiplied by everything in the second expression. So a -4 times the square root again gives us a -4 times the square root. And a -4 times -4 gives us +16. So now we can start reducing. So as 6x plus 16 and plus 16 is +32. And then -4 gives us a total of -8 times the square root. So we still have the x underneath the square root. We're going to have to square both sides again. We're going to try to get the square root part completely alone by itself, which will make the squaring, this time all the square roots will cancel out. So let's subtract 6x from both sides, so -4x over there. And subtract 32 from both sides, -32. And we'll leave it over here as 8 square root of 6x plus 16. So now we can square both of these sides, and we're going to have the square roots cancel out. So on the left side we have to do FOIL again, or distributive property. FOIL is the shortcut for remembering that. And over here we're going to have 8 times 8 is 64, and then the square root times the square root is just the value underneath the square root. Okay, and so I'm going to have to come up here, make a little bit more room. And so -4 times -4 would give us a +16x squared. And then -4 times -32. Let's just pull that up. 4 times 32 is 128. They're both negative, so we'll have a +128x. And then the same thing here, -32 times -4x is a +128x. And then 32 times 32 is 1024. And on the other side, we have 64 times 6 is 384x. And then 64 times 16 equals 1024. All right, so reductions now, we have 16x squared. And on the left side here, we have 128 plus 128 for 256x, but we're minusing 384. So it's -384. And that's to get all the x's on one side. So I'm going to minus it from both sides. So we'll have minus 128x. And then if we minus the 1024s from both sides, they would just be gone on both sides. So our right side now is 0 because we've subtracted both of these terms away, and we've reduced everything on the left. So now we can pull a 16x out from both of those. So 128 divided by 16. 128 divided by 16 is 8. So we would have 16x, and that's multiplied by x minus 8 equals 0. So we have two factors here multiplied together equal to 0. Either the first one has to be 0 or the second one has to be 0. To make 16x equal to 0, x would have to equal 0. To make x minus 8 equal to 0, we would have x has to equal a positive 8. So those are our two answers for x. And you do always want to go back to the original equation. You squared both sides. Make sure that your solutions you reach are actually legitimate answers. Plug them both in. If you plug in a 0 everywhere, you're going to get 0 on both sides. Or sorry, yeah, you'll get 0 on both sides. And if you plug in an 8 everywhere, you're going to get 4 equals to 4 on both sides. And since plugging in the values gives a legitimate result that the equation's equal, then we verify that these are our two solutions, and that's our final answer.